Bismillahirrahmanirrahim. Assalamu alaikum. This is Dr. Nosheen Tariq Siddiqui. We were discussing the chapter rheology, in which we have discussed the important aspects in rheology, in which we have done the Newtonian fluids and the non-Newtonian fluids. Among the non-Newtonian fluids, we have seen there are time-dependent and time-independent fluids. Among the time-independent, we have done the dilatant and the pseudoplastic materials. Now we are going to discuss the time-dependent material, the fluids, which has a rheological behavior. These are thixotrophy. But before going to thixotrophic material, I'll discuss something. I'll discuss pseudoplasticity again, so you'll have a clear idea what is thixotrophy and how, because you know the thixotrophy, it is somewhat related to pseudoplasticity, but there is a difference. So we'll see what is pseudoplasticity again, and then we'll go to the thixotrophy. Pseudoplasticity is basically what it is: shear thinning behavior, which is often referred to as pseudoplasticity. Means if you put pressure or you put force, or there is a steering or there is shear stress, then your material is going to be less viscous. Okay, pseudoplastic materials tend to become more fluid the faster they are stirred. How? The faster you are stirring, the faster the your material is going to be thinner, and it will be less viscous and more fluid-like. Weakly flocculated suspensions, polymeric solutions, these are the examples of the pseudoplastic systems. कौन से? Weakly flocculated suspensions, polymeric solutions such as solution of tragacan, sodium alginate, and cellulose derivatives, and semi-solid systems containing polymer components are example of pseudoplastic material. And about the rheogram and the viscogram, rheogram begins at the origin, indicating that the particle bonds too weak to withstand the applied shear stress. इसका जो ग्राफ बनता है वो origin से start होगा, क्योंकि जरा सी ही फोर्स अप्लाई करने से क्या होगा, आपके शेयर फोर्स अप्लाई करने से रेट इंक्रीज होना शुरू हो जाएगा, विस्कोसिटी कम होना शुरू हो जाएगी. ठीक है, तो इसलिए आपका ये ओरिजिन से ही स्टार्ट होगा. द इंक्रीज इन द रेट ऑफ शेयर इज ग्रेटर देन द कॉरेस्पॉन्डिंग इंक्रीज इन द शेयर स्ट्रेस, रिजल्टिंग इन द rheogram being a curve. इसका जो rheogram था वो कर्व था. डिक्रीज इन विस्कोसिटी इज ऑब्जर्व. rheogram कैसा है? ये ऊपर की तरफ जा रहा है. अब इसको आपको समझना है कि shear stress और shear rate of shear जब बढ़ता है तो आपका rheogram ऊपर की तरफ जा रहा है, और वो एक certain point पे आके, even if you are applying more shear rate, but it is not producing any or shear stress अभी आप provide करें तब भी वो liquid उसी तरह से रहता है. And this ये जो है वापस भी आ जाता है, यानी time independent है. तो ये जब आप इसकी शेयर या रेट या फोर्स आप रोकते हैं तो ये वापस अपनी फॉर्म में आ जाता है. ठीक है, बट थिक्सोट्रॉफिक में क्या होता है ये मैंने एक्सप्लेन कर दिया था कल कि ये इस तरह से होते हैं. पॉलीमेरिक सॉल्यूशंस, पॉलीमर्स जो होते हैं वो डिफरेंट बड़े बड़े माइक्रोमोलिक्यूल्स होते हैं ना बेसिकली. तो इसके साथ में जो मैक्रोमोलिक्यूल्स होते हैं, जो स्ट्रेस जो आप प्रोवाइड कर रहे थे उसके अलाइन होके जो मैंने आपको बताया था कि वो मूव करना शुरू कर देते हैं along the axis. Now what is time dependent non-Newtonian fluid? Thixotrophy, you can say, are similar to other shear dependent materials like pseudoplastics, but with one added variable, that they are time dependent. The variable is that they are time dependent. They are like pseudoplastic, but they are time dependent as well as they are time dependent as well. Therefore, the viscosity is affected by both shear rate and time it takes to recover. Basically, both the variables, that is the shear rate and the time, they both affect it, because in thixotrophy, when you apply force, it will, the viscosity will decrease, but it like pseudoplastic, it when it is जो उसका ग्राफ है वो जिस तरीके से बढ़ रहा है ना उसी तरीके से वापस भी आ रहा है, लेकिन इसमें थोड़ा सा डिफरेंस है। एक एग्जांपल मैं आपको दूंगा फ्रॉम अ हाउस होल्ड, that if you know take ketchup is a very good example of flow behavior. If shake the bottle vigorously to pour the ketchup, but you have only have if you shake bottle and you take out the ketchup, you have very short time when it regains that viscosity again. If you will keep it for some time, or you keep it stagnant or motionless for some time, so the ketchup will regain its viscosity. Okay. Like this, many formulations like coating and covering, they take advantage of this shear and the time dependent behavior. It basically it uses this behavior. Okay, because as I've told you, what that pseudoplastic में क्या होता है कि viscosity decrease होती है with increase rate, and recovery जो होती है वो along same path होती है. Okay, thixotrophy. In the previous discussion for shear thinning system, it was assumed that the system adapts itself to changing shear instantaneously, like in pseudoplastic. That is so fast that the rheogram at increasing or decreasing shear rates is a single curve. The thinning and the thickening is going is so fast that the rheogram जो है वो basically is a single curve. However, if the suspended particles are larger, or if the suspension is viscous, if you see same scenario, but the suspended particles you have, they are more larger, and they are the suspension, if the suspension is more viscous, the Brownian motion is too slow to restore the broken interparticle links instantaneously. What would happen? If it's very viscous, तो जो Brownian movement होती है वो restore नहीं कर पाती फौरन, क्योंकि मटेरियल मैंने आपसे पहले भी बताया था कि इसको ये सब चीजें डिपेंडेंट है, मॉर्फोलॉजी पे भी डिपेंडेंट है, इंटर सर्विस जो मॉलिक्यूलर अट्रैक्शंस है उस पे भी डिपेंडेंट है विस्कोसिटी जो होती है. तो इसलिए ये इस पे करती है कि जो जब आप इसको थिन करते हैं broken particles हो जाते हैं. Of course, there is a Brownian movement in between those particles. So to regain that, the Brownian movement will again, start acting, but it will take more time, to make it more interparticle जो उसकी वो होती है उसको वापस linkage करने के लिए इसको it needs time. If the structure does not immediately recover, the descending rheogram will have the lower stress value at each shear rate, and the apparent viscosity will decrease even while the system is under constant shear. Such a body is said to be thixotrophic. Thixotrophy is therefore time-dependent breakdown or rebuilding the structure on standing, that is a reversible and isothermal formation of gel to solution. Example of this thixotropic material is bentonite sodium gel. This gel, it is kind of solid, and when you basically shake it, so it becomes a little what I can say, the viscosity its viscosity decreases because it is very viscous when it's in rest state, which then when stirred above the yield value, flows can be poured. You can pour it after stirring. When kept undisturbed for an hour, it reverts to gel as the Brownian motion rebuilds the house of cards-like structure. Okay, thixotrophy in a pseudoplastic system is shown in figure. I'll show you the figure. Starting with the system at rest, that is 0, O position, the following facts are observed in the rheogram for pseudoplastic system obtained by plotting shear stress versus shear rate. This is a graph of thixotrophy. What happens? Okay, वो जो आप upper curve देख रहे हो, that is similar with like the pseudoplastic, but the lower portion of the curve, this is not similar with the pseudoplastic because the system is taking time to regain its original position. So that's why you will get a two curves, and the in between the two curves, it is known as this area is known as degree of hysteresis. What it is showing that increased shear will decrease viscosity. However, decreased shear rate will result in a slower path or longer time to reform the structure and achieve full viscosity recovery. This, the difference between the downward and the upward and the downward curve is this is called the thixotrophic system and is known as degree of hysteresis. Just have to show you. Since product with higher molecular weight particularly take longer to recover, thus degree of hysteresis will be larger than the systems will cover with lower molecular weight particles. Since what happens that since product with higher molecular weight particle, it takes longer time to recover, then the degree of hysteresis will be larger होगी. अगर बड़े particles होंगे वो देर से settle हो रहा है, वापस अपनी उसमें viscosity में आ रहा है, तो the degree of hysteresis will be higher, while in lower molecular weight it will be lower. Okay. The two curves are obtained, an upper curve OAB when the shear rate is increased and a downward curve when the shear rate is reduced. The up and down curves are non-superimposable. In pseudoplastic, they were superimposable. They were superimposing each other. They were same. The line were same. But in this, the downward curve is displaced lower to the upper curve, indicating that the viscosity of the system at any rate of shear is lower on the down curve than on the up curve. Thus, the shear stress required to maintain the rate of shear reduced from S1 to S2, and the apparent viscosity drops from S1 to S2. This contrary to the rheogram pseudoplastic material, where the up curve and the downward curve coincide. Okay. Okay. How this thixotrophy is beneficial in the areas like paints and coating. I'll give you examples from the daily routines. Then, I'll take your class and we'll discuss this in front of you, and we'll give you examples from the pharmaceutical preparations. And then we'll discuss how, it is important. Okay, at rest, what happens? At rest, when shear rate is low, example, gravitational forces are low. If there is only gravitational force, if you think about paint, you think that at rest there is only gravitational forces on the store paint जो होता है उसके जब at rest होता है उस वक्त सिर्फ gravitational forces के ऊपर हो रही होती है ना, act कर रही होती है. तो उस वक्त क्या होता है कि it is in a very maintained या suspension form में होता है. Solid particles जो होते हैं वो बड़े अच्छे तरीके से suspend हुए होते हैं, यानी कि solid particles pigment की form में होते हैं ना, वो उसके अंदर suspend हुए होते हैं आराम से. What you do, you apply a force. How you basically shake or you basically put force through your brush, and then you take after doing that, after rolling in the paint, the viscosity of the paint decreases, which this decrease in the viscosity will facilitate the achievement for the uniform, the paint, you need a uniform covering over something. Okay, so what it does, it decreases the viscosity, so you will achieve this uniformity. And then how you do it after mixing the formulation, then you apply this with a brush or roller or whatever you or spray, even a spray. In that, while you're brushing or applying, you're basically what you're doing, you are applying more shear stress. You're doing it with force. You're applying more shear rate, so that will decrease the viscosity again. So while you're applying, it will decrease the viscosity and you'll apply with the uniform. Okay, what will happen? It will give you a full coverage, and it will it will help you to give a very full coverage. Means कि वो आपको बहुत अच्छा एक system provide करेगा, जिससे you will be able to put paint on all over the system, और जहां भी आप जिस दीवार पे करें, जहां भी करें, वो आपको पूरा पेंट आप उस पर आराम से कर सकते हो, और वो इवनली होगा, एक जैसा होगा. उसके बाद क्या होगा? व्हेन यू स्टॉप ब्रशिंग, तो आप क्या करेंगे? यू विल एलिमिनेट दैट फोर्स. आप वो फोर्स एलिमिनेट करेंगे, और उसके बाद क्या होगा? लो विस्कोसिटी जो है वो मेंटेन होना शुरू होगी. After a certain period of time, when the paint will be at rest, so viscosity वापस आना शुरू होगी, but it will be little slower, मतलब slower होगी. This slower time which it takes, इससे क्या होता है पेंट में कि जो मार्क्स आते हैं ना ब्रशेस के, क्योंकि स्पेशली ऑन अ वर्टिकल सरफेस, ठीक है, क्या होता है कि उससे क्या होता है कि वो चूंकि आहिस्ता आहिस्ता आ रहा होता है, उस पर सिर्फ ग्रेविटेशनल फोर्स हो रही होती है, तो जो उसके ऊपर जो लेयर होती है ना, उसके जो ब्रश मार्क्स होते हैं आपके ऊपर नीचे जो आए होते हैं, वो भी इवन हो जाते हैं थ्रू द ग्रेविटेशनल फोर्सेस, कि वो उससे जो है वो और ये जो आहिस्ता आहिस्ता जो ये स्लो प्रोसेस होता है, इसकी वजह से यूनिफॉर्म सी जो है ना कपलिंग आती है, और लेटर क्या होता है कि आखिरकार वो अपनी विस्कोसिटी रिगेन कर लेता है और वो बिल्कुल स्मूथ हो जाता है. ठीक है, तो दैट्स हाउ इट इज. अगर इफ यू keep in this in mind, it is important. So we'll discuss later among pharmaceutical preparations what happens. Okay, how you determine the rheological properties, the measurement of viscosity. The two basic types of instruments are available based on the material to be analyzed or the type of rheogram obtained. The material to be analyzed is to be keep in mind while determining, and the type of rheogram you want. One-point instruments, they provide a single point on a rheogram and are suitable for Newtonian fluids. The examples are Oswald viscometer and Doppler viscometers. While the multi-point instruments, complete rheogram can be obtained by characterizing the flow properties at variable rate of shear. These instruments are used to determine viscosity of non-Newtonian systems. Examples include cup and bob viscometer and cone and plate viscometers. Based on the principle of measuring viscosity, three types of viscometers are available. That is capillary viscometer, density dependent viscometer, and rotational viscometer. What is capillary? They are based on the rate of flow of a liquid through a fine capillary or orifice. Density dependent viscometer, they are based on the velocity of falling objects through a liquid under the influence of gravity. By rotational viscometers, they are based on the resistance of rotating elements in contact with or immersed in a liquid. Specialized pharmaceutical preparation applications of rheology. These are the a different type of applications, and you know what are the shear rate, or you have to apply a shear rate value on it. Squeezing from a tube, you require 10 to 100 shear rate value, which has pouring from a bottle. Topical application, rubbing an ointment, oil ointment, rubbing on to skin, or rubbing on ointment tile, basically when you're mixing and you're making a tile, rubbing onto skin, nasal sprays, pumping of products, and high-speed filling. You see how different shear rates are applied. Virology. What is virology? The study of flow and deformation in a biological system is called virology. The study of flow and the different deformation in a, when you study the system of flow in the biological system, means in us, okay, in the biological systems, whatever the biological system, the fluid in the biological system. There are different fluids in biological system, blood, head, different head, okay. So the study of these biological systems is known as virology. Understanding the rheological properties of biological fluid is important for successful drug delivery. Of course, if you know how your liquid is behaving, that is how blood is behaving, or the other carriers in which you are putting the drug, so you will, it is very important for your drug to be delivered to the body, and also for understanding the general state of health. The rheological nature of various biological fluids is stipulated. Now you can, you will understand what I am saying. The rheological behavior which you need to keep in mind and how they are. Newtonian fluids. What are the Newtonian fluids in our body? They are cerebral spinal fluid, bronchial mucus, and bronchial mucus. What is the utility in knowing is that the bronchospinal fluid, they act as water cushion to protect the spinal cord and drain from physical impact. And if it's not, if the fluid is not, in the same viscosity, then, it will not protect the spinal cord. Okay, तो ये जो cushion provide कर रहा है, इसकी due to its viscosity provide कर रहा है ना. Bronchial mucus क्या है? Viscosity increases in cystic fibrosis. जब bronchial mucus जो है, जब आपको cystic fibrosis होता है तो उसमें viscosity increase हो जाती है इसकी. Pseudoplastic synovial fluid, high viscosity at low shear maintains clearance between articulate surfaces, whereas the joint moves at higher shear, viscosity is lower and protect the cartilage from wearing. होता है क्या? जब at rest जो साइनोवियल फ्लूइड होता है, एट रेस्ट जो होता है, उसकी विस्कोसिटी हाई होती है. जब आप चलते हैं या भागते हैं, दौड़ते हैं, ज्यादा करते हैं, तो ये विस्कोसिटी कम होती है. इसकी वजह से क्या होता है? लुब्रिकेशन ऑल ओवर योर बोन वो बढ़ती है, क्योंकि विस्कोसिटी कम होती है, और इससे जो वेयर एंड टेयर है ना आपके बोन्स का, वो कम होता है. ठीक है. लाइकवाइज टेयर फ्लूइड जो होते हैं, टेयर फ्लूइड क्या होते हैं कि जब दे अलाउ ऑफ इफेक्टिव कवरिंग ओवर योर आई. तो जब अगर ये वापस जैसे किसी भी चोट लगने से क्या होता है, कुछ भी क्या होता है कि ये जो है विस्कोसिटी लोअर डाउन होती है, और ये जो है ना आग बहने लगती है, पानी आने लगता है. ओके, लेकिन अगर ये वापस ना जाए, अगर ये सूडोप्लास्टिक नहीं हो, ये उसी तरीके से वापस ना जाए, तो फिर तो वापस आपकी ये कवरिंग नहीं बनेगी ना. तो इसलिए दिस इज इम्पोर्टेंट. ब्लड विस्कोसिटी मींस increases in arteriosclerosis. Arteriosclerosis क्या है? जहाँ पे thickening of blood शुरू हो जाती है, deposition शुरू हो जाती है. Okay, arteriosclerosis में होता है viscosity increase होती है, तो आपका blood जो है वो आपके sides में blood vessels में stick होना शुरू हो जाता है. तो these are all जो है वो क्या? coronary heart disease, angina, myocardial infarction जो है ना, ये इसका cause बनता है. फिर GIT mucus, you know that altered rheology of the GI mucus barriers results in ulcerative process. If अगर viscosity इतनी नहीं रहेगी तो क्या होगा? alter करने से GI के अंदर of course आपकी ulcer produce होना शुरू हो जाएंगे. Okay? Viscoelastic, nasal mucus, semen, cervical mucus, and vitreous humor. These all are viscoelastic. Increase in mucus viscosity indicates sinusitis and chronic inflammation. If we have increased mucus viscosity, and if we don't have the semen or cervical mucus की अगर आपकी viscosity नहीं होगी proper, तो spermatozoa की transfer it's become easy. Okay. Medications produced as semi-solid type products such as creams, ointments, and lotions are based on emulsion or suspension type system consisting of two or more incompatible materials. क्या होते हैं यूजुअली जो आपके मेडिकेशंस, कौन सी टाइप की क्रीम्स, ऑइंटमेंट्स एंड लोशंस, दे आर बेसिकली इमर्जेंस होते हैं. सस्पेंशंस, इसमें क्या होता है कि 2-3 टाइप के आपके इनकम्पैटिबल मटेरियल्स होते हैं व्हिच आर पुट टुगेदर. इन ऑर्डर टू be manufactured, these dosage forms need specific flow property, so they can be placed into a container, remain stable over time, dispensed, handled, and properly applied to the affected area by the patients. Rheology is therefore crucially important as it will directly affect the way a drug is formulated and developed, the quality of the raw and finished product, the drug efficacy, the way a patient adheres to the prescribed drug, and the overall healthcare cost. All is dependent on rheology. It can be concluded that there are inherent and independent factors that affect the flow property of medicated material during every stage of its manufacturing, all the way to its use. So rheology will be, you will affect all from the manufacturing to the prescription or prescribed or to the use. So rheology is important to understand. Okay, I'll discuss now. I'll discuss in your class all the equations from the Newtonian fluid, the non-Newtonian fluid, and we'll discuss the application of rheology in the pharmaceutical preparation. We'll consider each the pseudoplastic, the dialing type, and the other type, and we'll discuss this in the class with examples. Okay, thank you very much.